All right, guys, in these two problems up here, it says we want to write the equation of the ellipse that meets the following conditions. So if you look at this first one, it says the semi-major axis has a length of 2 square roots of 13. Semi-major, that's going to be our A value. So right away I can say A equals 2 square roots of 13. And the foci are at -1, 1, and -1, -5. So if I graph that really quick, let's see here, -1, 1 will be back up here, and -1 and -5, -1, -5 will be down this way. So this is going to have a vertical orientation where our major axis is going to go vertical. Okay, if I find the point in between those, -1, -2, that's going to be our center, right? That's going to be our H and our K values. Okay, so I need a couple other things here. First off, I think I can find my C right away, as this is 3 units in between. So my C is going to be 3. And then to figure out my B value, what I can do is use the equation A squared minus B squared equals C squared. So if I fill those in, A squared, well 2 squared is 4, square root of 13 squared is 13, 4 times 13 is 52. So 52 minus, I still don't know B squared, C squared is 9. If I subtract 9 over, that's going to be 41. No, it's not. It's 43. 43, and then if I add B squared to the other side, equals B squared. So 43 equals B squared. That's going to be good to know. And then we also need A squared. I think we said earlier was 52. So 52 equals A squared. So what can I do with all that? All right. I need to write out my equation, and this is one where the y's are going to come first since it is vertical. We're going to do y minus my k. Y minus -2 is y plus 2, quantity squared. Over A squared we said was 52 plus x minus my h. X minus the -1 is x plus 1, quantity squared. All over B squared. B squared we said was 43. Okay, and then every ellipse equals 1. So this is the equation of that ellipse. If we look at the next one, it says the foci are at 3, 5, and 1, 5. So if we go up 1, 2, 3, 4, 5, 3, 5, and 1, 5. Those are our foci. This one's going to be oriented horizontally, and in between those is 2, 5. 2, 5 is going to be our center. So our center is 2, 5. Again, that's our H and our K values. And then this says this has eccentricity at 0.25. You want to probably think of that as a fraction, and of course 0.25 is 1/4. So eccentricity, remember, it's the equation E equals C over A, where if I replace this with what I have, 1/4, now my C equals 1 and my A equals 4. So the only other part I need now is the B. And B, again, we can use our equation that we used over here. A squared minus B squared equals C squared. Right? And if I fill in with what I know, A squared is 16. I don't know B squared, but I know C squared is 1. So if I subtract 1 over, I get 15, and add B squared to the other side, I get B squared. So 15 equals B squared. A squared would be 16. And that should be enough to write out my equation. Let's try it. Again, this one's oriented horizontally, so the x's come first. X minus my h, x minus 2, quantity squared. Over the a squared, we said was 16. Plus the y's, y minus my k, minus k squared, which is 5. Y minus 5, quantity squared, over b squared. B squared in this case is 15. And again, every ellipse equals 1. Okay, so this is the equation of the ellipse that satisfies those conditions.